Hello friends, in today's class we are going to talk about example 4 of 3 address code generation. Welcome again, and here we are discussing another example of 3 address code, and it's a while loop and until a of I is less than equal to v. Okay, so a of I is less than equal to v is an array, an integer array where size of this integer array size of integer is equal to, let's say, 4 byte. Okay, so now we want to translate this, and ideally I should write this t1 is equal to I plus 1, and then I should write I is equal to t1, and then I have to check this condition, and here a of I need to break it down, and I will say that what is the extension of this? So this is a base address plus I minus 1 into size. Okay, now why I'm writing this thing over here and when it should be applicable. Now for this array, A is an array, and if I just denote this thing as an one-dimensional entity, suppose this is the address 0, that is one case. Suppose the element is 1, 2, 3, 4 and 5. Suppose there are 5 elements are there, and if this is the address 0 and if it is 4 byte, this will be 4, this will be 8, this will be 12, and this will be 16. So if the base address is 0 and I want to access the, let's say, second element, okay, second element, that is 0th, 1 and 2, second element, in that case I have to write here I minus 1 into size. So I can get my address over here, that if it is my indexing starts with 0, in that case I minus 0, or otherwise if indexing start from 1, then I should write I minus 1. So into size. So there are two conditions are there. This is for indexing start from 1, indexing from 1, and this is for indexing for 0, index from 0. Okay, sorry, this is 0. Now, so in this case, if I want to access the second element, this is indexing is from 1 to 1 and 2, this is the second element, and it will become 0 plus 2 minus 1 into 4, and it will become 0 plus 1 into 4, and then answer will be 4. Now if the index is 0, so this is 0, this is 1 and this is 2, in that case it will be 0 plus, and here it will be 2 minus 0 into 4. In that case it will become 0 plus 8, and it will become finally 8. So here there are two different answers are there, and in this case my answer is 4. This one, if I start indexing it from 0, and in another case answer will be 8 if the indexing is from 1. So that really affects the calculation, and we call it that the lower bound, lower index, lower index. So lower index is 0 or 1 or any other general bound, it affects it. So here what I'm assuming is AI, the size of address is 1 byte, and suppose I'm assuming that index is from 1. Index is from 1, lower index is 1. So in that case this formula is applicable, and this calculation I have to perform. Okay, so what I have to write here in this case is a T2 is equal to I minus 1, and then I have to write if okay, one more statement is there, that T3 is equal to a of t2, and then I'll write if a of t2 is less than v, then I will write here go to let's say L0, and let me call it as L0. So this is the way we, and otherwise what otherwise will come here, and I'll just say end. Okay, so now this is the case where we are using this I is equal to I plus 1 do. This is the body of the loop, and then I have just this calculation is there, t2 is equal to I minus 1, and finally I have done this t3 is equal to a t2, and then this is the condition checking, and this is the taking jump here. Okay, so I hope we are clear, but this is a single dimension array, 1D array, and that's why we are facing not very difficult situation. The case will be complicated when we are talking about a 2-dimension or let's say 3-dimension array. When we flatten this one, that we represent the entire array in terms of 1D array, 1-dimension array, their problem will occur. But here, these two things I have given to you. So size matters. Okay, it's a size matters, and second thing that matters, the index matters. Okay. So that's all for this. Thank you.